Hi everyone, I'm very much excited to come your way with the second session of our lab activities for the semester. Today, I would want you to lend me very few minutes of your time so we can understand the objective of the session. Today, we are going to look at how to analyze the composition and the concentrations of flue gases and also determine their efficiencies, the efficiency of combustion, I mean. Well, if I may ask, did you really know that the generators you have in the schools, in the factories, in the huge industrial areas and other places all emit gases? And have you thought about the kind of gases that they emit, whether they are good for the environment or not? So today is the right day and time for you to be able to understand all of these things that happen in our environment. So today, we are not just going to measure gases, but we are going to demonstrate the capabilities of real engineers to understand the efficiency of combustion engines and whether they are safe and whether they are compliant. So stay with me as I move along with you. Before we can do this, we are just going to use a device where we call the flue gas analyzer. So this is the flue gas analyzer. This is the device. And so with the device, you see we have different configuration. This is the analyzer. And then this is the probe. So with this probe, you have the tip here. We will connect the tip to the exhaust of any combustion machine. It can be a generator. So the tip will take the flue gases through this tube and then into the analyzer to determine what component we have. And then over here is the printer. So this printer is going to print out the output of whatever composition the generator or the combustion engine is actually emitting to the environment. So over here, this is the on button. You can just put it on. And when you put it on, the device actually calibrates itself. Or let me say a zeroing of the device. So you can see here the zero gas sensors. So it means that it has to be left in the open air so that it can really calibrate itself. And then we are sure to obtain a very good and accurate results. So this is the calibration or the zeroing of the gas. So everything is now perfect. Before we move on to the actual experiment for the day, I would like also to explain the components we see on the flue gas analyzer. So we have here the T stack is just the temperature of the surroundings or the ambience. So it's about 24 degrees Celsius. We have the oxygen concentration. We haven't started yet. So you see the CO, which is the carbon monoxide in parts per million. We have the CO. Also, then we have the effluent. We have the ExAir. And also we have the CO2, which is the carbon dioxide. So like I said, in simulating a combustion engine, I have with me here a mini generator with a 2 horsepower. So we are using this generator as our equipment or as our machine to burn the fuel and then see what comes out of the exhaust. It can be a vehicle where a vehicle, as the fuel is being burnt, the exhaust of the vehicle, release some gases. So today we are going to use the mini generator. And the mini generator, so before I start, I'll have to put my valve on. Put my valve on here, good. And then there is the fuel valve. There's a fuel valve. I need to put the fuel valve also on. So I put it to the on position this way, good. Then the choke valve, I'll need to push it to the start position. And then I'll pull my string to start the generator. So 1, 2, 3, remove. Good. Good. So now we have our generator on, our combustion engine is on. So I would first have to actually zero my analyzer. So I click on the zeroing. So the zeroing should be in air to calibrate the analyzer so that I am sure of the results that I am going to actually obtain. So this is very crucial, it's very important, so as to have a very good results that you can be in a good position to interpret them. So this is the zeroing phase. So after the zeroing phase, I will have to insert the probe, the tip of the probe, into the exhaust and then measure the flue gas. So now it is done. Let's move on to measure our flue gas. So over here, I will insert the tip into the exhaust. Then I'll click on start. So finally, we have our measurements here, and you could see the temperature of the exhaust is around 112, which is quite a bit relative. The oxygen percentage is about 14%, which is quite high, because ideally it should be around 2 to 5% optimum. The carbon monoxide is around 7,000 ppm, almost 8,000 ppm, which is quite very high, because ideally it should be around less than 100 ppm. And the carbon monoxide undiluted is actually about 26,000. That is very extreme. It gives you the true value of the pollution, and the efficiency is very low, which is 74.3%. Ideally, you should get efficiency of about 85% and above, so it means it's very low. Too much ExAir, which is about almost 190%, and the CO2 concentration, which is quite okay, 3% is also good. But overall, you can see that we are having a very much incomplete combustion because we have too much excess air. So this air is not engaged in the combustion, but we are just, heating it and wasting energy and wasting fuel. If you see, the carbon monoxide is too much because it should be around less than 100 ppm. So this actually tells us that our combustion is not efficient. It's actually not efficient, because the CO here is really toxic. And let me give you an insight. Why we say CO is toxic is that, oxygen actually naturally binds with hemoglobin in the blood. So it transports oxygen to your brain and other parts of your body. But if you inhale this CO into your lungs, what happens is that this CO has a binding energy 2,200 times stronger than that of oxygen. So it bounds the hemoglobin and restricts oxygen supply to the brain and the heart. So if you didn't know about the toxicity of CO, I'm sure today you know about it. So you have to take care of the gases that come out of the devices that we use in your vehicles. You need to keep attention to how much and what composition of combustion gas or flue gas you are actually emitting into the environment. And I think if we have an idea and if we know this, it's going to go a long way to preserve our environment and to preserve our health as well. So to finally conclude, we'll have to print our results. So this is our printer here. It is connected by Bluetooth. So I put them together this way, and then I'll click on the print button. So if I click on the print button, then it shows printing. So I'll wait for the printer to actually give me the output of my results. So based on these results, I can put it on file or put it on record to show or to prove, the data that we have actually obtained. So over here now, you can see our results being printed perfectly. So you can just take your ticket. So if you're an environmental engineer who has been stationed to monitor the flue gases of vehicles at some particular point, or in industries, you have your portable analyzer with you. As soon as drivers don't comply, you can just print out the ticket. So the ticket or the results show the composition, and then based on this, we can be able to protect our environment and our atmosphere and punish wrongdoers, people who do not take care of their combustion devices. I hope this experiment went well with you, and then if you have any queries, you can submit it via Blackboard, and then we will attend to it expediently. Thank you very much.